Thank you. All right. I'm Lex, the head of strategy. I'll just there is only one slide about us, so bear with me. We are an infrastructure company. We've been building essentially a data layer for the last 7-ish years, a bit more. We come from research and academia originally, so we started with, let's say, complex problems of personal data. One of the use cases we started with was actually genetic human exposome. So it's the genetic makeup of people in the Nordics for cancer research. We did that with Karolinska Institute. And so it's always been at the forefront of what we were doing to consider how do we store, how do we manage, how do we give access, and so on to the data. And so that's sort of what I would like to talk about today. So first of all, perhaps a small definition, because we've been asked quite a bit in the last year and a half, what does it mean? And I think at the core, it's really building and operating your own AI system, compliant with your own regulation, but within your boundaries. So may you be an organization, may you be a country, may you be maybe eventually an individual. This is the sovereignty in the data and AI management. It's like operating within a certain set of boundaries and being able to operate a full AI system if you so can. So, okay, but why? Maybe, asking the original questions. So I have an anecdote. People tell me it's nice to start with an anecdote. I used to live in China about that time frame. So I arrived in China. We had Google, we had Facebook, we had about everything. And evidently, progressively, it started to sort of deter, and you wouldn't have access to those things. And one of the biggest breaking point, I would say, in the Chinese policy was around 2017, 2018, when Huawei was not allowed to operate with AT&T and do business with them. And so at that point, the Chinese government, rightfully so, decided to essentially decouple from the rest of the data ecosystem and, by and large, build their own. And so obviously everybody has heard of DeepSeek and these sort of things, but also they have made massive progress in their own infrastructure. And for example, in Europe now, Alibaba Cloud is slowly getting traction for the same reason. It's like they build those clouds that they didn't have. They were as dependent as everybody else on everything, American mostly. And so sovereignty can come also from that side, evidently. But it's also a matter of ownership of the technological stack. So that's the Financial Times. That's January 3rd, so 4 days ago, where essentially OpenAI said that they will have an OpenAI for countries offer. And one of the interesting part of the article is the one that I highlighted. Say, well, the company will own every layer of the tech stack, from data centers to the data foundation model to the user interface. And your data as well as users, as organizations, as company. So, it's sort of important to understand why they do that. I'll skip this one, but the reason they do that is really a matter of market. It's a market share, right? So part of this content is generated, so that does the small logo, but I verified the numbers. The thing is, it's essentially a matter of market shares. So 70 or plus of the models originate from the United States. 80% or plus of the AI infrastructure in Europe is actually also originating from the US. And so while we talk about the market shares and all, that means there is over 200 to 300 billion a year in terms of market, let's say, spending that is actually moving to the US and not being reintegrated in the AI cloud or the cloud infrastructure locally and so on. So, there is a market reality as well there. And so architecturally, how does it look like? It's essentially something like that, because eventually you also have your own infrastructure, maybe your own VMs or your own local infrastructure. But you send that data away to an AI service provider, typically an LLM like OpenAI, Claude, so Anthropic or the like, or Gemini. And so you are sending money and you are sending data over there. They operate within their cloud infrastructure, so they pay for the compute there and sends back to yours. And you have to rely on your own compliance locally, but they don't really have to. So the compliance aspects within that bundled service is usually not the same as yours. So there is a bit of distance here. So where do we operate our current infrastructure in that context? So typically what we have seen, because we are in industry, right? So we work only in large companies, is that in the last couple of years, there was a little swing back to on-prem. So a lot of the late boomers, right? They didn't go to the cloud, they were happy, they stayed on-prem. And some of the cloud providers, some of the cloud consumers said, well, we want a bit of on-prem. But then there was a new thing coming with all this sovereign AI thing. So they say, well, we can maybe move back to a sovereign cloud instead. And so obviously big cloud providers thought, well, that's a really good idea. That's what we're gonna do. So that's also June 3rd. It's like, okay, AWS, Microsoft, now saying, we're gonna give you actual sovereign cloud. If you read the print, the little prints, you say, well, okay, but the parent company remains under American ownership, which means at the end of the day, maybe your data is located physically somewhere here, but still regulated somewhere else. So, is it marketing? Always has been. It's always just a matter of consideration, right? So maybe there is a possibility for, a little bit of a different momentum where maybe it moves to hybrid. Maybe you don't need to, not have cloud providers, or you don't need to have everything on premise. Maybe you can have a bit of both depending on the use cases. So how can we do that? So in practice, you will have your data sources as such. You have something that happens and you want a prediction. That's how we do AI in a nutshell. And the real big deal is what happens there, right? So, and there it's all mostly Pythonic programming in operation and MLOps. So the data cleaning, the pre-processing, fine-tuning, yada, yada, it's all there. And so how could you make that part sovereign? Because eventually this is the part that needs to be managed mostly. Yeah, maybe you're not gonna change your data sources. Maybe you're not gonna move everything away, but perhaps you can actually manage the program aspects of it. So option one, sovereign laptops. That works to a large degree. Because you can have everything at least partially on your laptop and you can work on it. Evidently, if you have personal information from a company on your laptop, not tip-top, so maybe not the ideal option. Current option, which I sort of mentioned, is like, well, you have the sovereign clouds aspect, which is, I think this is just AWS S3 bucket, for example. You can have that locally, but eventually you might as well end up sending data to other providers, as I mentioned earlier. So maybe not ideal either. So how can we do a bit better? Maybe first, what do we need to solve here? So residency, regulation compliance, avoid lock-in, and allow for audit transparency. Another thing that's also tremendously important in that context is the operational aspect. Reuse, updates, monitoring, retrain, latency management, collaboration, resource and compute management, so on and so forth. So all of that ideally should be in that little box in the middle. So how can we do that? Well, luckily we work in Python, and so we have actually a little bit of liberty. We can use quite the frameworks we want for all of those portions. The way we divide it is in this, what we call the FTI pipelines, so feature, training, and inference. And sort of a separation of concern depending on what category of programs do you need to produce. And by doing that, it helps quite a bit in actually modularizing the system, and so that each program has its own concerns. So let's move that a little bit up, and you will have your sources, a feature engineering pipeline, and eventually a team or use cases. And I added human in the loop. This is mostly for LLMs, but evidently, you can also have like some frameworks there in between. So you need a bit more than that. You will need response logging and you need monitoring. Typically, response logging to see for A/B testing of the models and so on. And yeah, you have some interesting system here. Now, the problem is you can't exactly do that. You can't exactly pass the feature data to the training and to the inference. It's not really practical. The reason for that is because you don't always need to retrain a model, for example. And you don't necessarily always need to recompute features all the time, or not all the features. So you can't really have a system that just passes on to the next box right away. Ideally, you need a data layer. So manages the residency, regulatory compliance, prevents locking if possible. If you don't have the programs directly in it, allows for audit and transparency, but also allows for those two things to happen, which is eventually you also don't have to move all the data. With the OTF, the open table formats, getting all the craze right now, you can also perhaps mount them. You can just point to the data sources and retrieve it when you can. And if I have time, I can actually show that later. But also, you can actually store the response, the logging, the monitoring, etc. We built something like that. It's abstracted architecture. That's not how everything works, but that's essentially how we build the thing ourselves. So the idea that we have is that we shouldn't force users to define and choose which Python framework they would want to use. There is so many that's actually emerging, that are created, etc. And so, just use whatever you want. And we, as a platform, try to be just the abstracted data platform from that. So external tables when necessary, offline tables when you deal with large data sets, and online tables when you deal with very low latency, freshness features, and then the rest. So, okay, what's the role of Python in all that? Or in general, in that context? It's the economy, stupid. So I don't know if people know that reference. I know my colleague told me, well, I actually don't know the reference. So I realized people might be a bit younger than I know. So it's a political strategist for the Bill Clinton campaign, the first one, the one he won, that said that on TV. When I say, well, what does matter? He said, it's the economy, stupid. And that sort of stuck. And the idea behind is like everything is about the economy eventually. And in context of Python, it's sort of the same. It's economical because it's open source, it's modular, and often interoperable. And that's true for many other frameworks, evidently. But the thing with Python is like, well, it's awfully popular, so it makes more sense. It's not always the best that wins, it's just sometimes the one that's the most used because there's just more diversity in the ecosystem for that. And that's definitely the case for Python. So can we make an AI factory that is a bit more Pythonic and perhaps more sovereign in that context? So here I put a small Kubernetes logo, which is just for the kicks, but eventually you can deploy our platform fully on Kubernetes. But that's also something that you can see a lot in the industry. A lot of those platforms and the data layer can be also containerized, so you can actually just manage it yourself. So the way it could work, or the way it does work in context of what we do, is always that depending on the use case, you bring the tooling that you require. And by separating the concern between engineering, training, and inference, you can always pick the best tool for the job, essentially. So for example, in context of batch processing, you can use DuckDB, PySpark, Pandas, Polars, EvanSQL, and with a Python API or something. And for training, scikit-learn, PyTorch, TensorFlow, etc. By decoupling the data layer from those concerns, you can just essentially pick always what's best, eventually with the best SLAs. And that's the same for real-time. So in that case, maybe there is a bit less Pythonic framework for real-time processing, but they all usually have a Python API or way to communicate with the Pythonic word, so you can make it accessible. That's the case of Flink, for example. And so you can always, again, decouple the data layer and the data management from how you need to process that data in practice and use the best tool. And works the same for LLM. I kind of removed the training pipeline here, which is not exactly, I mean, you can fine tune it and you can train LLMs as well in that fashion, but typically people are more consumer of LLM than training a full foundation model. So in that context, using the same thing, you can always kind of decouple. Sorry. All right. That's something we do. I'll just show it later. That's as well. Let me actually show you the platform because it's much nicer and show you how that works. Yep. Not look at my password. Boom. So when we said that we actually decouple everything and we bring things, the most important part of the thing is really the data sources. So you don't always have the luxury of the choice of choosing where the data for AI is built, right? So maybe it is actually in an external table that is maybe not that sovereign, etc. So in our case, this is just a BigQuery table, which I will pick, and I'll just show you what you can do with that later. So I actually pick a random one. I don't know what's in it. So I pick that table. And so what happens here is that I actually do not write data in the platform. it just registers that table here, transaction. And suddenly it gives me a few superpowers. One of the superpower, evidently, is to add tags. And I can create a schema. I'll say sovereign, just sovereign data. And I'll add a property. I'll make it Boolean. And I'll create this new tag. So is EU a new tag? And I'll just register that transaction table. So the table doesn't exist in the platform at all, right? What I can do here is actually decide if this is data from EU or not, right? And when I will create and query this table for creating models, I can always double check or create rules to actually prevent EasyU data to be used, for example, in the US or things like that. Evidently, there is a bit more. You can set alerts when people are trying to do it. You can actually add rules for expectation and so on. But the idea is here that you can register data sets, search them, etc. Now, at the end of the day, you want to use Python. So we deploy Jupyter instances, but the thing is that what we do is we actually do create those environments prepackaged. So the benefit here is that you don't necessarily have to actually manage those libraries. You can, if you want, you can create your own environment package and you can manage those libraries, but it comes prepackaged, so it works off the shelf right away. So that's the one I will use. And we follow that logic actually that I mentioned earlier. Depending on the use case, you can run a job or run Python with that preset set of libraries that you need. So as I said, I don't really need anything else than this one. I actually already run, I can just stop it so you can see it. I just use the base environment here, but it could be, PySpark environment or something else. Just once again until it launches. So we do resource and compute management for the ones amongst you that are interested. So that's typically because in very large organization, you have a budget for compute depending on your business unit and things like that. And it might not be totally correlated with your project. It might be different depending. Let me just, okay. Let me try again. Here we are. So that table that I registered, super. Beauty of live demos. My colleague told me not to use the dev machine. I should have listened to him. Okay, I can show you the code anyways. I think it doesn't matter in itself. So that, or does it? I can show you in another one. Sometimes you try it like 20 times before, and you bully the machine, it breaks, you didn't know, and then you go, you do your demo, it doesn't work. It's amazing. I just switched to the demo cluster, which is a bit more sturdy, but it's an older version, unfortunately. So, yeah. Let me just try to query it. Let me try to add a new table. Well, everything works as expected. I do have internet, so it's all me. I have like 3 contingencies. All right. Okay, do I have the tables here? Deviation from policy. Yes? Well, I'll end up showing just GitHub repositories in my code, I guess. So what you can do once you have all of that registered in Avstreikh, when you're not using the dev machine that maybe somebody is working on, I hope that's the case. What you can do is essentially then do all your operation without talking to the platform. So this is why what I was talking about, abstracting away the infrastructure from essentially the processing that you do, the training, the inference, and such. So the idea here is that there is really little Avstreikh all over here, I mean, besides connecting to the project, and everything else is really doing data engineering and pre-processing exactly the same way you would do it otherwise. The only aspect of Avstreikh here, which is querying the data, is essentially happening somewhere here. Once you register this data set, you can query it, you can just show the data frame, you can query and you can make the joins without actually creating your own joins. So if I had a more complex data set here, I would just register it as a feature group, and then when I query it, I just say, give me the 5 column in that feature group, the 5 there, and the 5 there, and I will retrieve this as a pure data frame. So all the, is it online, offline, is it somewhere else, is it an external table in BigQuery, is it locally in S3, is it whatever, that's all abstracted away. You just get back a data frame, and you do whatever you want with it. And so you can do fine-tuning, you can do hyperparameter optimization, you can use subset of that data to do whatever you want. And that's sort of the benefit that I was trying to showcase with huge success at the moment for reasons unknown. But yeah, that's essentially it. And so typically what you would do is then train your model. In that case, you can save it in Avstreikh, you don't have to. So one of the things we try to do is not to actually force the users to use a specific set of tool set. So you do use whatever you want to do. What we force the users to do is to use a certain level of abstraction that enforces the ability to use those tool sets. Maybe it's a bit verbose, but the idea behind that, say, you do the bottlenecks on the feature storage so that all the data can be reused everywhere, whether you use our model registry or something else, regardless. And so that actually participate in that data reuse logic. And yeah, I really wished I could have showed the demo. But that's about it. That's all, folks. Oh, and you can try it for free. The one deployment that is actually working at the moment. Unfortunately, we don't provide with compute, I should mention. So you won't have Jupyter notebooks and all, but you can use it as an external data storage. So you can actually retrieve the data frame right into it and so on, just from VS Code or whatever. You don't have to use the Avstreikh storage, the Avstreikh Jupyter instance. And in that case, you can actually deploy an online model as well. There is an online database that is available. You have maybe limited in the number of queries, it's capped. So you can't like totally abuse the platform. It's a serverless platform, but you can actually deploy model online and use them in real time. So you can embed them in applications and so.